Hi, Evergreen. Let's do Chapter 6, Lesson 3, the parallel postulate. So these are all the rules about parallel lines that help us prove that parallel lines are parallel. Let's dig in. Get your book, open it up to page 225. Get your paper and your pencil and let's go. So we're going to build a construction first. So this is what it talks about on page 225. We're going to learn how to draw a parallel line. So if we're given a line, how to draw a parallel one with using our compass only. So our steps are to draw a line, number 1. 2, place point P somewhere above your first line. This is what it shows in your book, where you want to create your parallel line. Then place a point O on your starting line. Then you connect points O and P. This is going to be your transversal line. And then we're going to copy an angle. We're going to copy angle O, which is formed with your first line and your transversal line. And we're going to copy this angle at point P, making point P the vertex of this angle. Then, once we have that angle copied, we are going to draw a parallel line using that point P's angle. Okay, so that's the words of the steps of what we're going to do, and now I will show you. Follow along with me if you want.
Let's do our construction number 7 in lesson 3. So this is 6-3. We are going to learn how to draw a parallel line. So the first thing that we're going to do is start off by drawing a line. This is on page 225 in your textbook. So we are going to draw a line. We're going to name it L. I'm going to put some arrows to make it look like a line. Nice. We're going to put a point anywhere we want, but we'll put it there, point P. And we're going to put a line or a point on our line, point O. This is going to be one of our parallel lines. We're going to create our transversal line right now by connecting these points. So this will be our transversal. And our goal is to copy angle O where angle P is so that we can have corresponding angles. So the way we're going to do that is we are going to grab our handy dandy compass and we are going to create an angle. So let's make an angle. This will be kind of small. I don't have much room up here. So this will be our angle right here. And I am going to, oops, I'm going to move this out of the way. I am going to create an arc. I have to find my spot. There it is. On angle O. And then I'm going to put the pointy part of my compass on point P. And I'm going to replicate this angle by drawing the same arc. Okay. Now, remember how we copy an angle, we are going to measure the distance where the arc touches our angle legs or sides. Matched up perfectly, the best we can. Okay, so you see how it's matched with the distance? And so, I'm going to take, let's see, if I put my compass here, you can see exactly how I'm going to replicate that. You see how the pointed side is on the line that touches the arc. I'm going to do the same thing up here. There's the line and there's the arc. And I'm going to intersect the first arc. Now I can put a point where those lines are intersecting. And I'm going to draw a line connecting these two points. I will name this line M. And I know that these are parallel lines. Line M is parallel to line L because they have corresponding angles. This is the same measurement as this is. These are corresponding angles. Awesome. That's construction 7. Make sure you do that along with me or right now.
Okay, so if you haven't done construction 7, go ahead and do that. And we are going to keep going. So postulate 7, the parallel postulate, that's what this whole lesson's about. Through a point on a line, or sorry, through a point not on a line, just like we did in our construction, point P, there is exactly one line parallel to the given line. So if you have one parallel line, like parallel line M, and you have one point, you can make a parallel line using this point, just like we just did. And then theorem 18, in a plane, two lines parallel, 1 and 2, to a third line, are parallel to each other. So if 1 is parallel with 2 and 2 is parallel then to 3, then all are parallel together. And so therefore they will all have the same supplementary angles, not supplementary, corresponding angles, because they have the same transversal line going through them. Let's start on our lesson. So turn to page 227, and we're going to do 5 through 10 together right now. So windshield wipers. One type of windshield wiper has two blades that remain parallel as they move back and forth. Can you imagine that? And in this figure below, the lines of the wipers are A and B. Do they look parallel to you? They do to me too. And what does C look like if we imagined A and B extended? Does it look like a transversal line? Yes, that's what it is. And so we can imagine this up and down if you would like. You can kind of turn your book even if you wanted to look at it that way. But we know what these angles, 1, 2, 3, and 4, have relationships that are true because A and B are parallel and C is a transversal. So let's talk about this. Number 5, which angle corresponds to angle 1? Well, which one is a corresponding angle? Angle 3. 1 and 3 are in the same position above the parallel line on the right side of the transversal. Number 6, it says, if these two angles are always equal, why do the wipers always stay parallel? Well, the lines of these wipers always stay parallel because equal corresponding angles mean that lines are parallel. So this is going to be using the information in number 5 that these angles are corresponding, meaning that these lines are parallel. Number 7, what are angles 2 and 3 called? So 2 and 3 with respect to lines A, B, and C. So if A and B are parallel lines, that means that 2 and 3 are interior angles, right? So the interior angles on the same side of the transversal. That tells us where these are. Number 8, if these two angles are always supplementary, right? 2 and 3 are supplementary, they will add to 180. And we can kind of see that. 2 is acute, 3 is obtuse. And so you can imagine just looking at this that they really are supplementary. And we know because of our theorems, but it's just always nice to see that it looks like it as well. Okay, so if these two angles are always supplementary, why are the wipers always parallel? Well, let's use our rules. Supplementary interior angles on the same side of a transversal mean that the lines are parallel. So we're just using our rules that we have learned in the past to prove why A and B are parallel. Number 9, name another pair of angles that, if they are equal, would ensure that the wipers are parallel. So we know that 1 is equal or congruent to 3. We know that 2 is congruent to 4, correct? So this just names one of them, 2 and 4. Could we have named 1 and 3? Yes, we could have as well. Okay, number 10. If 1 and 4 are supplementary, yes, 1 and 4 are supplementary, why does it follow that the wipers are parallel? Why or why not? Well, we know that angle 1 is equal to angle 3, and angle 2 is equal to angle 4. And so the answer is yes. 1 and 2, or 3 and 4, are a linear pair. See how they make a line, 180, connected by a line, by a betweenness ray. If angle 1 and angle 4 are supplementary, then 2 equals 4. Or 1 equals 3. Because supplements of the same angle are equal, it follows that the wipers are parallel because they form equal corresponding angles with the transversal. That's the really main part. But yes, because they form equal corresponding angles with the transversal. And you can talk about some of the angles that are equal. 1 and 3, 2 and 4. Okay, let's go over here. I'm going to leave you to do 11 through 18 by yourself because they're easy. And they are going to be talking about exactly 1. I think you're going to be able to do this one by yourself. But 19 through 24, let's just do these together. So a parallelogram. The figure below shows a method for constructing a parallelogram. Well, that seems like it's easy to do, right? Because you see the 2 parallel lines and you see 1 transversal. So this basically just has 2 transversals, correct? And when we have 2 transversals that are parallel also, does that make a parallelogram? Yeah, because we have AD and BC that are parallel, going horizontally, and then not quite vertically, but to an angle, we have AB and DC that are also parallel. So the same rules that are true for parallel lines and 1 transversal are also true if you have 2 transversals, or a parallelogram as they're going to call it here. So let's look at this. Draw 2 intersecting lines and mark points A and B and C on them as shown in this figure. So basically you're going to copy this figure. Use your straight edge and your compass to construct a parallelogram ABCD by copying angle 1. Okay, so first you're going to draw BC. Okay, and then you're going to draw point A, just like we did on our construction for point P. You're going to draw point B next. And then you're going to copy angle B at angle A. You understand this? Okay, so after you've constructed this, let's look at number 20 together. Why is AD parallel to BC? Using our rules, let's think about it. And CD parallel to BA. Well, this whole lesson has been about angles that are in the same place, right? So let's see how they phrase it. They form equal corresponding angles with a transversal. That is the math way to say that. Number 21. What else seems to be true about segments AD and BC, as well as about segments CD and BA? Well, I would say they all seem to be equal. AD is equal to BC, and AB is equal to DC. Good. Now, number 22. What relationship seems to exist between angle 1 and BCD? So basically angle 1 and angle C right here. What seems to be the relationship? Well, they are both interior angles. And so angle 1 and angle ACD are going to be supplementary angles. Now let's look at angle 1 and ADC. Angle 1 and ADC. So D is right here. Now, angle 1 is opposite of angle B. That means they are congruent. Now, angle B would be in the same position as this empty spot right here, right below angle D. So therefore, we know because of their relationship and where they will be equal because they are vertical angles in the same position with the parallel lines and the transversal lines. Number 24. Does parallelogram ABCD appear to have a line of symmetry? So could we fold it anywhere to make it exactly the same? We already know it's exactly the same length on top and bottom, left and right, but we aren't dealing with right angles. We are dealing with angles that are obtuse and acute. So could we fold this to make it exactly line up? Any angle, top vertical or horizontal, or from corner to corner? The answer is no. It can't be folded so that the two halves coincide. So the answer is no, it does not have a line of symmetry. Okay, you did it! You did a great job. I'm so proud of you. I hope you have a great day. I'll see you later. Bye.